Hello and welcome to the presentation on communicating sequential process. My name is Parin Patel. I am a graduate student at Texas A&M University Kingsville, majoring in computer science. What are communicating sequential process? In the field of computer science, communicating sequential process is a language for describing pattern of interactions in concurrent systems. CSP was highly influenced in programming languages like OCaml, Limbo, and Go. OCaml is a concurrent programming language, Limbo is a distributed programming language, and Go is a programming language which is open source by Google. Applications of CSP. CSP was used in IMOS T900 9000 transputer to test the correctness of both processor pipeline and virtual process managed off-chip communications for the processors. Another application of CSP is like to detect deadlock on live lock in a critical systems that is safety related by uh, Daimler bins. Now, what are deadlocks? Now, deadlock is a situation in which two or more processes are unable to proceed because each is waiting for one that other to do something. Live lock is similar to deadlock but slightly different. It is a situation in which two or more processes continuously change their state in response to changes in the other processes without doing any useful work. Now, what are CSP primitives? Basically, there are two types of primitives that are events representing communication or interaction and primitive processes. To understand the CSP primitives, we need to understand what are events. An occurrence that is sharply localized at a single point in space and an instance of time is called events. For example, in a vending machine, a simple vending machine, insertion of a coin is called event. Getting out the chocolate, extraction of a chocolate is a call another event. On a bigger example, on a wider scale, let's say a complex vending machine. For an events of a complex vending machine is like insertion of first penny, insertion of second penny, extraction of a small biscuit or a cookie, extraction of a large biscuit or a cookie, and change if it breaks for a small chocolate, it needs to get some change to the customer back. So these are all events for the complex vending machine. Now, what are called alphabets? It is a set of events which are considered relevant for a particular description of an object. The alphabets for the process P is denoted by the symbol alpha. For the simple vending machines, the alphabets are coin in and chocolate out. For a complex vending machine, alphabets are insertion of first penny, insertion of second penny, small chocolate or cookie, large chocolate or cookie, and return of change. CSP notations. A prefix notation operator combines an event and a process to produce a new process. For example, if an X be an event and pre is the process by the event, then it is represented like X. It is pronounced as X then P. Describes an object which first engages in event X and then behaves exactly as described by P. The process X then P is defined to have the same alphabet as P. Now let's understand the CSP with examples. A simple vending machine which serves customers before breaking, that would then a CSP notation that for that it would be coin, then it comes to a stop. We need to note here that the processes are on the right side and the events, a single event is on the left side. Another example of a CSP when that is uh, vending machine which serves two customers before breaking would be coin, then chocolate, coin, then chocolate, and then it comes to a stop. It is denoted by the operator on the screen. Now, recursion. It is an extremely important concept while describing behavior of a system which eventually stops with time. It would be a tedious job to write down the full behavior of much shorter notations. To get rid of this, we have a recursive notation in CSP that is called mu. An example of a recursion is like it's a clock which does nothing but tick. Now here the equation of for the clock has some obvious consequences which are derived by simple substituting equals or for equals. Here the clock equals tick then clock. Now the clock is a recursive function again. So substituting this equation into the second equation would be tick, then clock. Likewise, we can derive an n number of equations. To reduce this, we can squeeze those equations and write a notation like this on shown on screen. It is a notation of a CSP to write a recursive function. Now let's look at the concept in CSP called choice. By means of prefixing and recursion, it is possible to describe object with single possible stream of behaviors. For example, a vending machine has a choice of slot for inserting two penny or one penny. It is up to the customer what he does. Choice is denoted by a vertical line that is called bar and pronounced as choice. Let's let's look up an example of a choice. A machine which offers a choice of two combination of change of 5 penny that are 1 penny, 1 penny, 1 penny, 2 penny that makes a total of 5 penny. And another combination is 2 penny, 1 penny, 2 penny and rest. So it's gonna be like change for 5, inserting a 5 penny, out 1 penny, out 1 penny, out 1 penny, and out 2 penny. And the choice of returning the second choice is out 2 penny, out 1 penny, out 2 penny, and so on. Now let's take a look up at a more complex example of a choice. If a vending machine which offers a choice of coins and choice of goods and also the change. So here's the example. A vending machine complex which gets 2 penny can offer a large coke or like large goods. Then if the customer wants a small one, then it needs to return 1 penny. And if the customer inserts 1 penny, then he can only get a small thing. And if he inserts one more penny after inserting the first penny, then he can have an option of going for the large thing. Here we need to note that if a customer inserts one more penny, it would come to stop. So there would be a warning of do not insert 3 pennies in a row. Mutual recursion. In mathematics and computer science, mutual recursion is a form of recursion where two mathematical or computational objects, such as functions or data types, are defined in terms of each other. Two functions are said to be mutually recursive if the first calls the second and in turn the second calls the first. Now let's look at an example of a mutual recursion. So a drink dispenser has two buttons labeled orange, excuse me. The actions of pressing the two buttons are set orange and set lemon. The actions of dispensing a drink are orange and lemon. The choice of drink that will next be dispensed is made by pressing the corresponding button. Before any button is pressed, no drink will be dispensed. Here are the equations defining the alphabet and behavior of the process DD. The definitions using two auxiliary definitions of O and L, which are mutually recursive. Alphabets of drink dispenser are alphabets of orange and alphabets of lemon, that are set orange, set lemon, orange, and lemon. A drink dispenser sets as a customer walks into the drink dispenser has two options: go for set orange or go for set lemon. If he goes for set orange, then it would be in this state, like to dispense the orange, or set lemon to go for the lemon state, or set orange that is already in the orange state. For the lemon, if he goes for the lemon, then it would be at the lemon state. If goes for the lemon, then it would have an option for set orange to go back to the orange state, or set lemon, which is already in the lemon state. This is a mutually recursive thing. Another important concept in CSP is traces. A traces of a behavior of a process is finite sequence of symbols recording the events in which process has engaged up to some moment in time. Let me correct this. So it is a recording of in which states the machine has been on a piece of paper. We can say that. Example of a traces would be like this. A trace of a simple vending machine at the moment it has completed serving of its first two customers would be coin, then chocolate, then coin and chocolate. It is mentioned in the angular brackets. The two angular brackets start of the bracket and the end of brackets. Our presentation has come to an end. I hope you like to press these presentations. If you have any questions for me, I would be more than happy to help you out. This is my email address on the screen. Sorry, this is my email on the address on the screen. Alright, thank you so much.